Welcome back. Let's continue creating our dungeon crawler, and I would like to make a start with changing levels, as in going up and down stairs. I don't think we'll fix that in one go, but we'll see how far we get first. I want to quickly look at our tech depth and see if we have anything we need to do there. So let's see. So what I think is we have some to-dos. So we're missing tests for these functions that convert between the coordinates and directions in game logic space to the ones that are understandable by RealityKit. So I think we should create some tests to make sure that these keep working correctly. And I think one way we could do that is to do something like property-based testing, where we're going to find various values for the anchor, position, and rotation, and add them to tests to see if these still work correctly. So let's get started. So one thing I do want to do is we're creating the quaternion here. I think it would be nicer if we could do that if we got the actual rotation here already, which means that we need to do a bit of shuffling around. And this should be a CG float. Or an actual float. Then I think these returns are no longer needed. Okay. This one now is already a quaternion. So games should still work as expected, because we didn't change the logic in any way. And I also want to rename this one now to float quaternion. Okay, now let's create some tests. So what I'm going to test is more or less these lines. I think we'll need a new test file for that, because this is about visualization tests. So we'll need testing, we'll need the game logic, and then we can create a new suite, converting from between game logic structures and visual representation. And the first test will test a couple of should return the expected position and rotation for specific start cases, test cases. Converting between game logic, position and rotation and visualization. So we have these. Now what I will do is I'll create, I want to get a couple, some test cases. So I'm going to do property-based testing, meaning I'll create some random test cases. I'll record what comes out of them as values. So I'll take a position. This will be a random position. And that's not how this works. So we have a coordinate. This can be random in between -10 and 10. Here again. We have a rotation or a heading. That's probably a better word. So this is a compass direction. Okay, so this can only work if compass direction is case iterable. I don't know if I can add that here. Then it's probably better to create a static variable random value. Then I need to switch on something like this. And then we have a position and a rotation. And then now I will print out the position, heading, the camera anchor position and the camera anchor rotation. And let's see what we get. This should be a function. Okay, so I have a list of, basically I got myself a list of test cases now. Maybe a bit too many, but let's see what happens. So the trick is I should now be able to take this one, create arguments, copy paste all this stuff in, and using some trickery okay, this is not how I expected this to work. Maybe we can do it a bit smarter. So what if I say this is a string and the string starts with opening parentheses, then I have my position, then we have a comma, then we have our heading, a comma, then we have our expected position, and then we have our camera position and the closing parenthesis. So we need to get rid of these for now. Let's run this test again. And now I should have something that almost resembles Swift code. Oh, and if I was really smart, I had added this comma as well. Okay. Oh, and I should have added these dots in front. I really just hope that it expects this as code now. This also requires SimD. This will be a compass direction. Uh-oh, I'll probably need to, you know what? It would probably be better to just say compass direction dot. And there was something like and a comma at the end. Let's give it another go. Let's see if we now have some valid code. Okay. Of course, this one now needs to take a test case. That's a tuple of a start of a position, of a heading, of an expected position, which is a SimD3 float, and an expected rotation that is a SimD quaternion float. Then we probably no longer need this. All we need to do is expect that if I take my test case .position to SimD, that this is the same as the expected position. And we also have a heading that we convert to a float quaternion, and we have a test case expected rotation. Let's see if this compiles. Okay, and these tests pass. And you can see that it added all these test cases. So we now know that if we start playing around with this function, we at least have a way of making sure that this conversion keeps working. Next, I want to get this out of this specific function because it's used in multiple places, not just the world update system. What we really need, I think, is we need to start looking for something like a view model. And for now, I will use that to place these ones in. And our world no longer needs this one. So let's run tests. Let's commit. Oh, we should then also update this. Okay. Next step. So if we want to go to if we want to have multiple levels, then we need to keep track of somewhere where the current player is. And I believe the best place to do that would be on the player itself. Let's first write a test and see if that helps guide us to a reasonable solution. So we still have our player movement. Maybe we should create a new suite that says that's about multiple levels. We're moving from one level to another. The player should take the new wall layout into account. Maybe this is even too big of a step. Let's just say that when a player moves up a staircase, the floor count number should increase by 1. And we'll call these floors. So I have a player. I'll say player dot go upstairs, sure. And then we expect player dot current floor to be 1. Maybe we start at 0. So we don't have to go upstairs, but we can add that one. I'll use the term ascend stairs. And we also need a current floor. Okay, we now have a passing test that just fakes what we need, but I'll commit it regardless. We'll just say test new player starts at floor number 0. Okay, now we need some logic. let's quickly commit this. Then let's say that we have a player. When a player is not on a staircase leading up, and let's get, we're moving from one floor to another. Should start at floor number 0 for a new player. When moving from one floor to another, should the should doesn't really help here in terms of text. Okay, so we'll move from one floor to another when a player is not on a staircase leading up, and the player tries to ascend. The floor number does not change. Okay, so now we need to make sure that we know where the player is. So if he ascends stairs, we'll probably need to have some form of map. This could be enough. Let's let it have pass in a map. Oh, and this should be a private set. And then we need the map here as well. Only this time it's also going, it has a, let's see, this will be stairs going up. Here the map can just be, oh, there no map is needed. So let's see what happens. Okay, so this fails. Let's see, our map has walls. If map array row column, if this is this one, then we say stairs up, insert coordinates. And then we can do something like func has stairs up at coordinates. This isn't very pretty, but it will probably be good enough. So we could say guard map has stairs up at our current position, else we return. Otherwise we increase the floor number. Okay. Let's commit this. Okay, I think I'm going to leave it at this for now. We have the absolute minimum of moving up a stair. However, the way we're doing this feels somewhat cumbersome. So I can imagine if we need to make functions for everything that can be there, maybe it also has a stairs down, or has a hole, or has a door. You get way too many of these, so we need to find a way of making that a bit easier. So I'll put that on top. Inspecting the map for features. That is something that we need to do. Then there is using stairs. That requires a map. Okay. I'm a bit curious to see if lots of functions will start needing the map, because if that gets passed in constantly, we might find a better way of maybe we need to associate the map and the player in a slightly different way if that's the case. And also, starting to call this function, we also need to find a way of calling the function from our game through our world, through the maps and the players. So it's starting to bit, but I don't know exactly what kind of solution we will arrive at. So for now, my strategy is to keep writing tests and see what kind of design that leads to. And for now, try to keep implementations as straightforward as possible to get a better idea about where the design is heading. And then we can refactor them a bit better. So I'm going to update our nodes, and then I'll see you in the next one. Start working on moving up and down floors. So first we refactored the conversion from game logic, coordinate and direction space to 3D coordinates and rotations, and then we added the possibility move up a floor and standing on stairs leading up. Okay, that's it for this episode. Thanks for watching and have a great day.